Hi guys, how are you all? Hi Lasya, hi Ashwath. What are you doing, Lasya, in school?
We finished exponential functions and regression.
Oh, nice. Okay. You finished exponential functions and regression. Okay. Did you do growth and decay, ma?
Yeah, we did.
Oh, you did growth and decay. Did you do word problems in that?
Yeah, we did.
Oh, wow. Okay. Then what are you currently doing now?
Uh, well, we finished the topic on Thursday, so we didn't start anything here. I don't know what we're doing next.
That's interesting. Okay.
But I think like she's doing something with polynomials next. I think.
Okay. What are you doing, Adyan? You're okay? What are you doing, Adyan?
On Thursday we had a quiz how we do like a number multiply no to the power of a fraction.
Oh, power of a fraction. You're still in radicals and exponents. Okay, I see. I see. Good to know. Last year, what was the module number, ma? Do you remember? What was the module number?
From our class?
Yeah, the current page number I know, but what is the module number?
12.2.
Hmm?
12.2. 12.2.
12. Okay, okay, thank you.
That's
12.
that's the homework you gave us last
Yeah, yeah,
time.
yeah, yeah. That helps a lot. Hold on.
Speaking of which, I had a question from you.
Yes, please. I would love to clarify. Tell me.
Page 545. I didn't get question 18.
540. Wow, I'm really proud that you're asking questions. The 12, right? Give a minute. Takes time. One second. 1 second. It takes time to download. Ma, give me a minute, ma.
Okay.
545. Last year 545. Okay, what is the question number? Last year, tell me the question number.
18.
Last year, something is really wrong because 545 I don't see 18. Do you have the question with you?
Um, well, it's like a giant word problem.
Is it 545, ma?
Yeah.
Can you read out the problem for me?
Um, it says two friends, Jorge and Mark, are taking a trip to the mountains for a camping trip, but they're not leaving together. Both friends separately record the distance they have each traveled from home every hour on the second day. The distance each friend is from his home can be modeled by a linear function of the hours spent traveling. Determine if the linear system um, created by the models for each situation has a unique solution with a positive value for time.
Okay, okay. My problem is, I think you are using a different book altogether. You know why I'm saying that? We are working on exponential functions. You're using linear systems, right? Can we see last year? It's interesting. Wait, 5:45, right?
Yeah.
Okay. Do you know how to find the ISBN number of the book, Lasia?
Yeah.
Hmm?
Yeah.
Yeah. Yeah. I'll do one thing. Wait. Let me go to the. It's okay, even if it takes time. I really want all of us to be on the same page, Amma. I feel there's a serious issue. Did you look at the ISBN number and buy? I don't think so.
You can give me the ISBN for the book and I'll get it by next week.
Okay, you don't have the ISBN number of the book. Next week, Lama, just message me, Ma. I think this is quite important.
Okay. Yeah.
Makes sense. Because something feels so wrong to me. Yeah, give me 1 minute. I'll also check. My Amazon order should contain my book, right? Something feels very wrong. One second, ma'am. Last year, is your book 2016? Is your book 2016?
It doesn't say.
It will say actually. Okay, this is the book that I'm saying talking about. Okay, can I message your mom?
Yeah.
Okay. Now, how are you going to send the question to me? I want to solve whatever question you're asking. Do one thing, Lasya. Take a picture, send it to me in WhatsApp. You have a mobile with you?
Yeah.
Something feels so wrong with the book and the
Oh,
page
really?
number. Okay, no problem. After the class, we'll do that. Shall we move on with the class? But you're going to send it after the class, definitely, ma, because I feel there's a huge issue. Is it
Yeah.
okay?
Yeah.
Okay. So I want to revise a couple of things and then move on. Let's see. Okay, how about this? How about this? Let's do this one and then we'll see. You did till page. I'll have track, ma, meaning I'll have track of the page numbers that I give as homework. And see, always you should check your answer, Lasya. Then only you'll get to know these issues. It tells me that you have not checked your answer at all. But that's okay. We'll iron this out now. I'm glad you asked. So we did till page number 555, correct? I just want to verify where we are. 555. Okay, we did only till 555. Okay, so there's more for us to go. So, hey, was it easy last year? Whatever we discussed, did it help you in school?
We haven't actually started covering geometric sequences yet.
Amma, there is no way, Lasya. Without covering geometric sequences, did they do exponential functions?
Yeah.
Not really. They would not have done that last year.
Pretty sure we didn't cover them.
Oh, really? Okay, interesting. Okay, you understand why, right? Exponential functions come from geometric sequences. You got it, right? Okay, I don't want to give you this right off. Okay, I had some other problems. Let's see. Okay, Adyan is also covering less in school. So let's see. 555 you did. Okay, so geometric sequences we did. Constructing geometric sequences is something you have to do. I think that you'll be able to. Let's see. Suppose there is a sequence 4, 12, 36, 108. 4, 12, 36, 108. 4, 12, 36, 108. Can you tell me the formula for f of n? I mean, this is what sequence. Based on that, construct the function. Can you do that for me or you want my help? Let me know. Ashwath, given this, would you be able to write the Ashwath, would you be able to write the sequence? You have to find the common ratio.
Yeah, I think so. Yeah. Miss Priya, can you please write out the formula? I kind of forgot the formula for this one.
Absolutely. But you should not be forgetting the formula, right? Meaning, why do you want the formula? You start with the first term and after that you multiply by r power of n minus 1, right? That's the formula given you. Usually they don't give you the formula like this.
Okay.
That's right. Did you get it, ma? Yes, I got two answers.
Wait, Miss Priya, can you show me? I forgot what ours.
Did you do the homework? Good job, ma. Did you do the homework, Adyan? Okay, common ratio. I'll quickly do this. Common ratio is
No,
successive term. Why my video is on. By the previous term. So any term 36 by 12 equal to 4. This number will be greater than 1 if it is a growing sequence. If it is a decreasing sequence, the common ratio will be less than 1. So this is 4. F of this is 12 threes are 36. I'm sorry. This is 3. And then the first term is 4. So when you put that together, the explicit rule says 4 times 3 power of r minus 1. In geometric sequence, usually you will write some restrictions. What is the restriction? N minus 1 here, right? What is the restriction in here? Restriction is n is greater than or equal to 2. Here, why? Because 2 minus 1 is a 1. So, let's say 4 times 3 is a 12, right? So, you should anyway have the first term. That's why you say n is greater than or equal to 2. Then only 4 times 3 power of 2 minus 1 is 1. 4 times 3 is 12. You see, this term you need, okay? You cannot, meaning, if you want to write out the first term, you need the zeroth term which is not in here, right? So you say n is greater than or equal to 2. From this term only you can start writing. You need your first term to be given to you. So you say n is greater than or equal to 2. Any questions, guys? Any questions? Adyan, did you get it?
Yeah.
Adyan? Okay, good. How about this? Now you're going to do this. I'm going to wait and watch. Okay, let's see this one. It's a nice one. Let's see. You're going to write out the sequence. You're going to tell me answers. Okay, let's see. Ashwa, this one, Adyan, I would like you to be able to answer. Can you give me 1 second, guys? I'll just go grab. My pen doesn't want to write properly, so give me 1 minute. I'll fix it. Sorry, guys. Tell me. Are you able to do? Were you able to do?
Can you give me a few more minutes to try?
Sorry, ma. What was that? What was that last year?
Can you give us a few more minutes?
Yeah. Sure. Meaning here the catch is to be able to just write the sequence first. You tell a number of friends about an interesting video you saw online. Each of those friends tell the same number of friends about it. The pattern continues and here is no repeat of the people told. The number of people who hear about this video through you form a geometric sequence. There are 256 people at the fourth round. Ah, that's so hard. Literally, if I were you, I would have written this. And in the sixth round, you have 4096. So, if this is the sixth term, this is the fourth term. Ashwath, what is that you can find, Ashwath? What is that you can find, Ashwath? Okay, last you got it, ma?
Find the fifth term, but I'm not sure how.
Yeah. So let's see this one. You can find the fifth term, but from 256, how did you get the sixth term? From 256, how did you find the sixth term? You multiplied by
16.
r. You multiplied by r. Where did that 16 come from? No, 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 no. Each this fifth term, to get to the fifth term, you multiplied by r and then you again multiplied it by r, right, ma? Right? No, now I can write an equation. Do you see it? 256 times r equal to 4096. Does that make sense? Divide by 256 on both sides. R times r will be equal to what? 16 twos are 32, 89, 16 fives are 80, 96, 6 divided by 16. So, do you see r square is 16? Do you see it? If r square is 16, take square root on both sides. R will be equal to
4.
4. So we got this. R will be equal to 4. So if we get R equal to 4, how to find the first term, guys? You know R is 4. So how to find the first term?
Dividing by 4.
Yeah, divide by 4. Again, one number you will get. Divide by 4. Again, you divide by 4. So 256 divide by 4. 256 divide by 4 is your G3 because that's the fourth term. This is G3, G2, G1, right? G3 is what? 64. Again, 64 divided by 4 is G2, which will be 16. This is 4. Now we formed our geometric sequence, right? Now let's see what do we want to do. We formed our geometric sequence. We really want to find the explicit formula, right? F of n will be equal to the first term times the common ratio power of n minus 1. Make sense? Make sense, guys?
Yeah.
Yeah.
Ashwath and Adyan, are you with me?
Yeah.
Okay, shall I go on and give you another
Yeah.
Yeah.
one like this? Okay. You should be able to write the restrictions as well nicely. Write this one, guys. On the deer population. We'll do one more problem on the deer population. Something very similar to this. Come on. You're going to try this one. Try this one, guys. Are you able to do, ma?
Yeah.
Do you get it?
Wait, Miss Priya, do we just type in the common ratio?
Yeah. You can tell me whatever you get. I'm okay. Step by step, you can let me know what you did. Good job, Lasya. Now you got a hang of it, Lasya. How to do that?
Yeah.
Nice to meet you.
Miss Priya, I got the answer, but I don't think it's right. And I don't
Doesn't matter, right? Send it to me.
Okay.
Yeah. Just send it to me. It's okay to make a mistake too. You can work it out on the board and we can see what the mistake is.
Okay.
Ah. Are you sending?
Yeah, I'm sending it.
How did you get that, Ashwath? The first one. Good try. How did you get that, Ashwath? See, your common ratio is correct, but your first term is incorrect. Your common ratio is correct, Amma, Ashwath.
Mm-hmm.
See, okay. In year 2 of the effort, the deer population, year 2, so this is G2, was 1200. In year 4, it was 1728. You got it?
Yeah.
So you found this out. R square, right? 1200 times R square will be 1728. So R square was what? 36 by 25, right?
Mm-hmm.
R was 6 by 5, right?
Yeah.
Now this is G2. What is G1? 1200. You always multiply by 6 by 5. When you go back, you should divide by 6 by 5. Did you do that?
Yeah.
So that is G1. What did you get? 1200 times 5 by 6, right? Was it not 1000? Ashwath, the first term was 1000, right? Adyan, I'm not getting answers from you. What's going on?
I sent my answer, but I got it wrong.
Ashwath, did you get it?
Yeah.
So where was the mistake, Ashwath?
Um.
Where was the mistake?
Second, let me try it again and tell you.
Yeah. I'm going to wait. At the same time, Adyan, are you able to do the homework first of all, Adyan? Did you get it, guys? Can I move on? Ashwath, did you get it? What was the mistake, Ashwath?
I haven't finished it yet.
Okay. Let me give you one more. How about this, ma? Would you be able to write an exponential function that passes through these 2 points? Would you be able to write an exponential function? Right? Ma, I'm discussing different flavors of problems. Write an exponential function that passes through these 2 points. 1 comma 3, 2 comma 9 by 4. Okay, can I do this problem? Generally, if they want you to write an exponent, see, explicit formula always concentrated on f of n is equal to the first term times the common ratio power n minus 1. Suppose if n was given here, n minus 1 was given here, correct? Now, the thing is, this was with the assumption that the first term was the first term, g1. All of you got it? Did you get it? Okay. Now, suppose if this becomes your 0th term, if this becomes your 0th term, this was the first term, okay? I'm also including my 0th term. What will happen to this? Let's consider this sequence, right? Let's consider this sequence, guys. We are going to consider 4, 8, 16, 32. Now, the first term starts with 4, correct? Now, what is the common ratio, Lasya, in this sequence? What's the common ratio?
2.
Yeah, 2 power of n minus 1. Now, unfortunately, what I'm going to do, I'm going to include another term. You got it? See, from 4 if I start, to get my 16, that's the third term. To get G3, you multiply 2 common ratios. Correct, ma? Now, unfortunately, I'm going to add one more term. So, if I start with a 2, how to get G3? How many common ratios are there from 2? 3. So if I include my 0th term, automatically the number of common ratio increases. So if I have f of 0, this becomes r power of n. Makes sense, guys? They both are one and the same. If you start with f of 1, this is n minus 1. If you start with f of 0, this is n because one more common ratio gets added. Ashwath, Lasya, did you get it?
Yeah.
How about you, Adyan? Okay, seemed to be having him. Adyan, did you get it?
I I wasn't here. My I wasn't here. It kicked me out because of my internet.
Now, let's go ahead and try this one. Write an exponential function that passes through. So hereafter, if you want to write an exponential function, I'm going to start with f of z. Let's see this one. Let's say, okay, I'm going to write an exponential function that passes through these 2 points. So generally, the general format of exponential function, I'm going to take this, okay. I'm going to start with a term and then let's see, one minute, 1 second. One second, ma'am. Okay. Okay. In this situation, I'm going to if I want to write my exponential function, I don't want to start with the first term. I want to start with my zeroth term. You got it? Then my common ratio r power of n. This becomes your general formula. Okay. Now the thing is, what is this f of 0? I have no idea what is this f of 0. F of 0 means 0 comma what literally is what I'm asking. I don't know. I have only 1 and 2 for x values, right? My n value is your x value, right? So that should be 0. I don't know, okay? So what I do, I take this as f of 0. F of 0, or I can call it as a r power of n will be equal to f of n, right? The nth term. So I can write this as gn. Gn means nth term in the geometric sequence equal to the first term, meaning the starting value times common ratio power n. So what I do, let me show you. Here r power of n, f of n. You don't know this, right? But you know this. This you know. Can we this? But this you know. We can easily find the common ratio. How to find the common ratio? How to find the common ratio here, Lasya? You tell me. How to find the common ratio? 1, x value 2 is given. That means what? You can assume that your first term and the second term is given, correct?
Yeah.
How to find the common ratio?
3 divided by 9 over
Successive term divided by the
1 over
previous
4
term.
divided
Don't
by
change.
4.
9 by 4 times 1 by 3. You see, the common ratio is 3 by 4. Any questions on that? If your common ratio is 3 by 4 power n, right? F of n is equal to f of 0 times 3 by 4 power n. Now, you know, can I put these two are points, right? Meaning if I write it in terms of x and y, right? How do I write it in terms of x and y? This is y will be equal to the first term. First term meaning will be equal to the first 0, meaning will be equal to the function value if 0 is given as the input times 3 by 4 power x. You see, n is your x value, f of n is your y value. Now, there are two different xy coordinates given. This seems an easy one. 1, 3 I am going to substitute. For x I will substitute 1. For y I will substitute 3. So, 3 will be equal to the first initial value times 3 by 4 power 1. If I do this, how to find out my f of 0? This starting value. How to find that? Multiply by 4 on both sides. Then you divide by 3 on both sides. So you get that the first term will be equal to 4. Now substitute that back into the equation. When I substitute that back into the equation, 4 times 3 by 4 power n. Makes sense, guys? Last year, did you get that? Ashwath, did you get that?
Yeah.
Okay, but before you proceed, one easy way to understand this is you are not starting with f of 1. Okay, you are going to the 0th term as well. So r power becomes n. Okay, so if you want to write it differently, always remember the exponential function is written like this. This is the same as this. Y is f of n. A is the starting value. B is the common ratio. Power n is your x value. This is an easy way to remember, so that first you find out the common ratio B, put that in there, and then you have xy value. Substitute that to get A. Once you substitute that to get A, you can substitute everything back to your original equation. Y will be equal to AB power of x and get the exponential function. Any questions, guys? Lasya, Ashwath, did you get it?
Yeah.
Okay, good. Okay, so let's see. I'm going to give you a very similar one. Last year, if your school did not cover that, I'm 100% sure that is your next topic. Okay, write the equation of the function that includes these 2 points. So first, you will start with let me give you the general formula now, but you should remember this, guys. You can either write it out as y equal to a b power of x. B is the ratio, a is your initial value. You can have this, or you can have as f of n is equal to f of 0 times r power of n. Both are one and the same, guys. Try.
Miss Priya.
Yama,
In this case, the successive term would be 2, right?
in this case, yeah, correct. Whatever comes after, divide by before. You got it,
Okay.
ma?
Yeah.
That's right. Good job. I think you're proceeding the right way. Did you get it?
This time show my answer.
I think that's right.
I'm confused.
You're confused? Okay. Adin, did you get
Me?
it?
I'm also confused.
Okay, no problem. How about this? Okay, so here, what is the common ratio? These are two consecutive terms. You see, minus 2, minus 1. These are two consecutive terms. So I can find the common ratio is equal to the successive term divided by the previous term. 2 times 5 by 2. So the common ratio is 5. This is 5. This is 5. Now I have I can substitute and say a 5 power of x. But I want to find out a, otherwise I cannot write the formula. But I do have several xy values. See, this is x comma y, this is x comma y. I don't want to go to fractions. I can substitute minus 1 and 2 for x and y. If I substitute minus 1 and 2 for x and y, I can find out a. What is 5 power of minus 1, Ashwath? What is 5 power of minus 1?
-5?
No, 1 by 5, right? Negative exponent is 1 divided by that, right? So, multiply by 5 on both sides. A will be equal to 10. Make sense? So, A will be equal to 10. Now, you can write out the function as 10 times 5 power of x, or you can write it out as f of n is equal to 10 times 5 power of n. Any questions, guys? Ashwath, did you understand?
Yeah.
If it is 2 power of minus 1, it's 1 by 2, guys. Did you all get it? 2 by 3 power minus 1 is what, Lasya?
3/2.
Huh?
3/2.
3 by 2. This flips, meaning the negative reciprocal means 2 power of minus 1 means 2 goes down. Denominator 3 power of minus 1 means it goes up. So it's 3 by 2 power 1. Did you get that, Ashwath?
Yeah.
Okay. How about maybe one more question? Yeah, let's try this. This is a harder one. After this, we'll go to polynomials. Let's see this one. After this, we'll go to polynomials. Maybe this week or next week. Okay, let's see. What did I do? Nothing got pasted. It's interesting. Okay, go ahead and try this one. See, the laser beam loses 1% power. Means what percent power continues, you have to think. Write it as a decimal. The laser beam loses 1% means what is the power that keeps going? That is what you need to find out. This is a little tricky. Let me see. If you're stuck, you can let me know.
Wait, Miss Priya, didn't we do it last week?
This one?
Yeah, the same question.
No.
I think it's 5 times 0.99
Wow.
from last week.
Very nice. But, oh, the same problem we did, huh?
Yeah.
Yeah. Okay. So the first term is 5. The beam loses 1% means 99% continues, right? 99% continues. Every time it's 99 by 100. 99 by 100 gets on multiplied to get the next terms. So the common ratio is 0.99, but the power Pn, number of reflections. So the power is a function of the number of reflections. So we did discuss, remember, any exponential function is given as a b power of x. A is your initial value, b is your common ratio. This can be n. If you put this as f of n, this can be n. So this has been put as f of n. F of n means the power function whose independent, meaning power function is dependent on n, the number of reflections. So you can write that out as p of n will be equal to 5 times 0.99 power n. Any questions, guys? Any questions?
No.
We did this now, then I don't know, meaning you, okay, I don't remember doing this though, honestly. Okay, let's see this one. I'm a little worried. Okay, after this one I'm going to move on, okay, to polynomials. Okay, let's see this one. You guys are moving too fast. Come on.
Yeah, is it a 1.5?
What, ma? Do you want to try or you want me to try? You have to let me know, guys. Did we graph exponential function in this class, ma? Not really fully. I want to graph and finish this class. Let's see. Let's see.
So
Go
for
ahead.
this one, would the initial value not be like the height it was dropped from. So we'd have to find that out.
Okay, what is given? Let me read. The height of a bouncing ball is an exponential function and number of bounces. One ball is dropped and on the first bounce reaches a height of 6 feet. Yes, 6 is not the 6 is the first bounce. So what is the initial value? See, because we are going to use the formula y equal to ab power of x, right? A is your initial value, the 0th term. Remember, ma? You are right. So the first term is given, but you will have to find the 0th term. Correct. Guys, we need to have 1.5 hour class, right? From next week we'll have it. From next week we'll have 1.5 hour class for 2 weeks because I'll have to make up one class. Lasya, will you remind me?
Yeah.
Did you get it, ma?
I sent you my answer.
After this, I'm going to graph and show you. With that, we'll conclude. Correct, Lasya. Ashwath, correct, Ashwath. But you have to simplify 4 by 6. You cannot write like that. Ashwath, your 0th term is incorrect. See, that's what I'm saying. If you write your equation as a b power of x, or if you write your equation as this is f of 0, this initial value, not the first term, even before that. Okay, but if you write your equation like this, f of 1 if you start with, r will be power n minus 1. Okay, to make it easy, we are following this. We are not following this, we are following this. Now, the first bounce is 6 feet. Means what is f of 0, Ashwath? This is f of 1. Ashwath, did you get it?
Yeah.
On the second bounce, it reaches 4 feet. So what is the common ratio? Successive term by the previous term, which is 2 by 3. That is correct. Okay. But what is the 0th term? How do you get it? F of 0, you just multiply by r when you go forward. You divide by r when you go backward. 6 divided by 2 by 3 is f of 0. 6 times 3 by 2, which is 9. You got it, guys?
Yeah.
Okay, now if I want to graph exponential functions, let me quickly show you how to graph an exponential function. It's not a hard one. Graphing is so easy, I'll tell you. Okay, how? Why? Let's see. I want to graph f of x. See, guys, they'll give you an equation. If they give you an equation, how to graph? F of x equal to 3 times 4 power of x. If they give you this, please form the table. Any function graphing, whether it is linear, see, make sure for x value, x is the independent value. Make sure it has at least two negative values, 1, 0, two positive values. Now plug this into the equation f of minus 2. I'm substituting x equal to minus 2. 3 times 4 power of minus 2. 3 times 1 by 16. 3 by 16. It's a very small number. F of negative 1. I'm plugging in x equal to negative 1 now. 3 times 4 power of minus 1. 3 times 1 by 4, which is 3 by 4. A little more, a little bigger number. 3 by 16 is so less, 3 by 4 is little up. Now f of 0. Substitute 0 in here. 3 times 4 power of 0. Anything power 0 is 1. So answer is 3. Now substitute 1. What is the answer? 3 times 4, 12. Then f of 2, 3 times 4 square, right? So that would be 16 times 3, 40. See, once you get the table of values, it's so easy to plot. F of minus 2 is a small number. 3 by 4 is a little big number. 1 is here, 2 is here. 0 is a 3. You see, it grows like anything. See, 3. 1 is a 12. 12 comes somewhere here. 2 is a 48. It goes above. So just connect these values. 0 is a 3, right? Just connect these values. Any questions, guys? Any questions?
No.
Now, one thing I want you to understand. See, this graph tries to merge with the x-axis, right? If you have a graph that is trying to merge with a line, right? X-axis equation is y equal to 0, correct? If a graph tries to merge with the line, that line is called the asymptote for the graph. Asymptote. A-S-Y-M-P-T-O-T-E. Asymptote of the graph is y equal to 0. Any questions, guys?
No.
Okay. Now, I gave you 3 times 4 power of x. Here your initial value of 3, and every time 3 was multiplied by 4, multiplied by 4, multiplied by 4, multiplied by 4. So it was a growing sequence. Do you see? It grows up. Whereas if I give you 3 times 1 by 4 power x, how do you think the graph will be? How do you think the graph will be? Can you graph this and show me and go? Graph 3 times 1 by 4 power x. Show the graph to me and go. At least plot 3 points. With that we'll finish.
Priya,
Yes.
you want me to show you the graph?
Yes, ma.
Wait, let me take my.
Yeah, you take your time, or a screenshot is as well is good. For me, whatever you have, you can show me. No hurry at all.
Can you see that?
Yes, but is that right, ma? Yeah, that's right. That's right. Good job. So, do you see how it goes down? See, x, y. Always draw the table, guys. Minus, let's say minus 404. I'll do only three values. If I put it like that, substitute x equal to minus 4. Ashwath, did you get it?
Yeah.
So that becomes y will be equal to 3 times 1 power minus 4. 4 power minus 4 becomes 4 power of 4. Right? This is 256 times 3, which is a very large value. This is 256 times 3, which is a very, very large value. That is for minus 4. It's a very large value somewhere here. Now, next substitute y x equal to 0. If you substitute 3 times 1 by 4 power 0, which is a 3. Right? So, x equal to 0 is a 3. Now, what happens finally? Substitute x equal to 4. What happens? 3 times 1 by 4 power 4, which is 3 by 256, which is a very, very small value. 3 by 256, which is a very, very small value for 4. See? So now connect these. Should be like this. Did you guys get it? This is a decaying graph. Exponential decay. That is why this number is less than 1. It keeps on getting multiplied. The number 3 gets on multiplied by 1 by 4, 1 by 4, 1 by 4. The earlier one was a growth graph, exponential growth, where it went like this. You got it? That's the difference. The value grows. Here the value decays. Any questions, guys? Any questions? Can I stop here? Can I stop here?
Yeah.
Guys,
Yeah.
okay. See you all next week. Have a nice week ahead. We'll start with polynomials, but please finish the homework. And last year, your work is to send me what is the problem with your book.
Yeah.
Make sense?
Yeah.
Yes. Bye, ma. See you all next week, guys.
Bye,
Bye,
Miss
Miss Priya.
Bye, guys.
Bye, Miss Priya. Thank you.
Bye, guys.